when there is when the velocity is changing constantly, then the term comes as acceleration. So it's common. We usually call, whenever you speed up your vehicle, you call it as what accelerating. So that is what the acceleration. We have discussed about what is the acceleration. We all know that it is the rate of change of velocity with time. Okay. So we have seen different types of acceleration, or uniformly accelerated motion and non-uniformly accelerated motion. When your velocity is constantly changing with a definite value, then what will happen? We can take under the uniform accelerated motion or uniformly accelerated motion. If it is not constantly changing, sometimes it will increase, again because some traffic will decrease, so again will increase. So that is what variable or non-uniformly accelerated motion. So similarly, we have also discussed about what is average acceleration and instantaneous acceleration as well. Okay, so we can see this different changes of the acceleration whenever the bodies drop from some height also. Okay, so suppose that there is some ball or something you can take. So at t equals to 0, it is here. Now it is at rest. So velocity is what? 0. Okay. So after 1 second it comes here. So after 1 second it comes here. So what will happen here? Velocity will become 10 when time equals to 1 second. Okay. So again it comes here. So we will become what? Say it will become 30. So you can say now time equals to what? 2 seconds. So again it comes here. So now velocity will become, say, some 70. So t equals to 3 seconds. So again from here, so it comes, velocity will be, say, 120 meter per second. This is meter per second, meter per second, meter per second, meter per second. Okay. So time equals to 4 seconds here. Okay. Now if you want to know the acceleration of every interval of time, if you look at acceleration every interval of time, so what is the acceleration here? We know that v2 minus v1 divided by t2 minus t1, or final velocity minus initial velocity divided by final time minus initial time. So what you can write here? Final velocity is 10 minus 0 divided by time is 1 minus 0 equals to 10 meter per second square. Okay. So in first time interval, in first second, its acceleration is 10 meter per second square. Okay. So similarly, if you calculate in this interval, in second time interval, so here what is the v2? V2 is 30. So 30 minus 10 divided by 2 minus 1. So 2 minus 1. So this will become what? 20 by 1. So again this is 20 meter per second square. Okay. In third time interval, final velocity is 70. Initial velocity is 30. Time interval is what? 3 minus 2. So 3 minus 2 is equals to what? 40 by 1. So that is what? 40 meter per second square. Okay. So similarly in the fourth interval, so what is final velocity? 120 minus 70 is initial velocity divided by time. Divided by time is what? 4 minus 3. 4 minus 3 is equals to. So what you can get? So this is what? Some 50 by 1. So you will get it as 50 meter per second. Okay. So your acceleration is also increasing constantly. Okay. So before it was 10 meter per second square, again 20 meter per second square, then 40, 50. Values are not having the constant gap, so we cannot say it is uniformly accelerated. It may be a non-uniformly accelerated. Okay, because here it is difference is 10, here it is 20, here it is again 10. So this is what I have calculated acceleration for unit time interval for 1 second. Can we calculate for 2 seconds? What will happen if I calculate for 2 seconds? Means from here to here directly. Okay, so that means I will come from here to here. Okay, so this is what your time interval. So what is v2? So So V2 minus V1 by T2 minus T1. What is the V2? V2 is 30 minus 0 divided by time is 2 minus 0. So 2 minus 0. So 30 divided by 2 is what? 50 meter per second square. Okay. So for two time intervals or for a period of 2 seconds, what I got is I got 15 meter per second square as the acceleration. You can see here the acceleration is 10, 9, 20, 10 plus 20. Divided by 2, you may get 15, but not all the time it's 10. So now here. So for second time interval, what is the initial final velocity is 120. Final velocity is 120 minus initial velocity. It will come here. Initial velocity will come here. What is that? That is 30. Initial velocity is what? 30. Divided by what is the final time? 4. What is the initial time? 2. So equals to what? Equals to, so this is what? This will become 90 divided by 2. That is what? 45 meter per second square. So acceleration we got, so 45 meter per second square. Okay. So this is what you can calculate the acceleration for a given interval of time. Now if you want to know what is the average acceleration, means acceleration over a total time period of time period. What is the total time period? This is what total time period from t equals to 0 to t equals to 4 seconds. If I calculated that one, so what will happen? So final velocity is 120, initial velocity is 0. So 120 minus 0, final time is what? 4 seconds, initial time is 0. So what you will get? You will get it as, say, 12 divided by, 120 by 4. So 4 runs are 4 3 are 12. So you will get it as 30 meter per second square. What is that 30 meter per second square? 30 meter per second square is the average acceleration over a time period of 4 seconds. Okay. So these are the accelerations over a time period of 2 seconds. These are the individual accelerations over a time period of 1 second. Okay. So like this we can calculate the accelerations for the freely falling body also. So far what we have discussed is we have discussed about the speed, we have discussed about the velocity, we have discussed about the types of speed, types of velocities, then under the variable velocity we have also discussed about the acceleration, again types of acceleration. Okay. So for all these, to calculate all these things, what we need some data. Okay. So they have to use some distance or some displacement, then calculating velocity, then we can say that yes, object is in uniform motion or uniform velocity. After calculating acceleration, we can decide yes, this is the uniformly accelerated motion or non-uniformly accelerated motion. Then by calculating the what velocity or acceleration, whether negative or positive, then we can mention we can understand the direction of object, in which direction it is moving. So for all these things we have to calculate something. We have to spend some time to calculate some value, then we can decide or we can describe the motion. Okay. Without doing all these calculations, can we tell something about the motion? So this is possible with another method, that is what the graphical method. If you look at the graph, you can tell its velocity is this much, or it is moving with a uniform velocity, or it is moving with a positive acceleration, or it is moving with a negative acceleration, without calculating anything, just by looking at the graph. Okay, so that is why the graphical representation of motion is very important. So today we'll start with again graphical representation of motion. Okay, so that is what graphical representation of motion. Okay, so what do you mean by graphical representation of motion? So here you have to plot the graph for any two given quantities, either it may be a distance time, or it may be a displacement time, or it may be a velocity time, or it may be a acceleration with time. Okay, that we will see later. Mainly in general we can use it as a position time graphs, that we have discussed before also, after the speed. Okay, so before going for that, we will generally know what exactly graph is and what are the things we can get from the graph. Once we understand the basic nature of a graph, then we can go with our graphical representation of motion. Okay, so for example, if suppose your object is in space, then what three axes are needed to specify the what? To specify the object or position of the object. Okay, so I am not going to take the three coordinates here. I will take not three axes, I will take only two axes. So this is what one axis, this is what another axis. This is the x axis, this side minus, so this is the y axis, this side minus y. So this is what one a system of axes. Okay, now before also I told you it is just like an empty bottle. If you fill the water, it will become the water bottle. If you fill the milk, it will become the milk bottle, like that. So what you take along the x-axis will become that quantity. What you take along y-axis will become that quantity. Suppose you take distance here, your y-axis will be what? It is a distance. If you take velocity here, your y-axis will be what? It is a velocity. This is if you take time, it will be a time. If you take some other quantity, it will become some other quantity. Okay. So in generally we can do it. Okay. So now I will take only positive side. Remember here what will happen? Your x is what? X is positive. Y is also what? Y is also positive here. Okay. Here this is 0. Whatever comes on this side is negative. Whatever comes on this side is negative. Okay. Here x is negative and y is positive. Y is positive. Here x is negative, y is also negative. Here x is positive, y is negative. Okay. Now, very important thing from the graph is slope. Okay. So suppose you are having a graph like this. Suppose you are having a graph, a straight line passing through the origin. Okay. Say here you are taking x and here you are taking t, for example. Okay. So now what this graph suggests is, this graph will tell you how x is changing with time. Suppose time is 1 second, so x may be some 10. That means in 1 second of time, distance traveled is what? 10 meters, like that. So suppose at t equals to 2 seconds, what is the time? Time may be say 20. Okay. So like that, at t equals to t1, maybe x is say x1. Generally I am talking. Maybe at t equals to t2, x is what? X is say x2. Okay, in general. Okay, so how your distance or x is changing with time, that is what we mainly get from the graph. One more very important thing from the graph is slope. This slope will help us to find many things. Okay, so suppose if you take distance and this as time, what is slope then? Slope is this one. This is what the slope. Okay, so this is what the slope. Suppose if you take A, B, C, so what you can write for the slope? You can write for the slope is y by x, means delta y by delta x. Delta y by delta x. This is what? From here to here is what? This is delta y. From here to here what? It is delta x, x axis. Okay, don't confuse with this x. Okay, so now can I write it as AB by BC? AB divided by BC. What is that? Delta y by delta x. Okay. So now what is delta y? Delta y is this one. What is that one? x2. x2 is, from here to here is x2. This is what x2 and this is what x1. Then what is this delta x? Delta x is x2 minus x1. So you can write it as x2 minus x1 divided by, what is this time? This BC. So this is what T2 minus T1. So this will give you what? Delta C. So T2 minus T1. So this is what your slope. This is what your slope. Okay. So it may be x, y, or s, whatever. So don't get confused with this x and that x. Okay. So this is what, how you can calculate the slope. So suppose this is distance and suppose this is the say displacement and this is the time. So what this will give you? Displacement divided by time will give you what? Velocity. So you can get one important quantity from the slope. Suppose this is velocity and this is time. Velocity divided by time give you what? It will give you the acceleration. So slope will always give some quantity which will help us to describe the motion. So that is why slope is very important. Okay. So slope you can take in other way also. Instead of calculating this one, if you know this angle, suppose say this angle is theta. This angle is theta. If this is theta, this is also going to be theta only. So opposite divided by adjacent is what? Tan theta. So slope is also what? Tan theta. Getting? So if you know the angle, from the angle also you can calculate angle made by the curve with the x-axis. Angle made by the curve with the x-axis. What you can say? A tangent of that angle is going to be what? That is going to be a slope. So now suppose your theta, if it is making say some 45 degree. So your slope is what? Tan 45. Tan 45 is what? 1. So slope is what? Slope is going to be 1. So directly what you got, if it is a displacement time, you will directly get your velocity as 1 meter per second. Okay. So that we will see later. Just remember slope is tan theta or this divided by this, opposite divided by adjacent. Okay. So now suppose instead of this one, if curve is something like this, so if you want to know the slope between these two, no problem, you can get the slope like this. You can get the slope. Okay. So this divided by this will give you what? A slope. Instead of that one, if you want to know the slope at the point, suppose if you want to calculate slope at this point, then how will you get the slope? So very simple. You have to draw a tangent. At that point. Okay. So what is tangent? It is a straight line touching the curve only at a single point. Okay. So if you draw the tangent at that point, to this tangent you can get the slope. So you can get the slope at that point. Okay. It may be smaller or it may be bigger, whatever you can take, that will give the same value. So this will give you what? This will give you the slope. So this slope will help you what? This slope will help you to find the quantity exactly at this point, exactly at that point. If suppose if displacement time graph, this will give you what? Instantaneous velocity. Okay, that we will see later. Just as of now, remember again, slope is what? AB divided by BC. AB divided by BC. What is this line? This line is what? This is what? Tangent. This line is what? Tangent. Okay. So slope to the tangent will give you what? The quantity. Okay. So this is what the basic of the graph. Basic of the graph. We will go with the graphical representation of motion. So we'll go with the position time graph. Position time graph. Okay. So already we have discussed about this one before also, but we will go a little more on that. Position time graph. So what actually position time graph is what? So along the x-axis, what you will take? You will take time. Along the y-axis, what you will take? You will take position. Position means what? Distance from the origin or distance from the reference point. Okay. So then, how we can define the position time graph? The graph in which position taken along y-axis and time taken along x-axis. Okay. So graph in which position taken along y-axis and time taken along x-axis is called as what? Is called as position time graph. Okay. So suppose now if I want to plot some graph for the motion. Suppose this is the origin, and when you start moving, so after 2 seconds it will come to 10 meter distance. After 4 seconds it will come to 20 meter distance. After 6 seconds it will come to some 30 meter distance. After 8 seconds position is what? 40 meter. Okay. So this is what, these are the what distances or displacement. Since it is a straight line motion, distance is going to be equals to displacement. So along the position means or position, always you can take it as what? Distance. Okay. So if you want to plot this on the graph, so how you can plot? You can plot it as, so time you take here 1, 2, 3, 4, 5, 6, so on, like. So this is what 0, 2 seconds, 4 seconds, 6 seconds, 8, 10, 12, like that, so on, like. Or you can take 1, 2, 3, 4, 5, 6, 7, like that also. So here I will take it as what? You can take it as 10, 20, 30, 40, 50, 60, 70, 80, like that. So what you are taking here? Position. Position means what? Distance from reference point, distance from origin. This is what origin. Here this is what origin. Distance from the origin. Time. Starting time here is 0. Here time is what? 2 seconds, 4 seconds, 6 seconds, like that. Okay. Now, in 2 seconds, displacement or position is what? Position is at 10. In 2 seconds, position is here at 10. So this is what the position. That is what the position. Next, after again 4th second, position is 20. At 4th second, position is 20. This is what? 20, and this is what? 4. Okay. So this is the point which you are going to get it. Okay. So similarly, at 6:30 is the position. At 6th time, at t equals to 6, position is what? Position is 30. So this is what? This is another point. At 8th second, position is what? Position is 40. Position is 40 here. So this is what? At 8. So this is what? Position. So what graph you will get? You will get a graph is a straight line passing through origin. Why? Because when time is 0, displacement, your position is what? Position is also 0, means distance is also 0. So your graph will be like this. This is what going to be your graph. Graph is what? A straight line. Now, here what we are having? You are having the distance and time, or displacement and time. Now, if you want to calculate the what slope of this one, if you calculate slope, anywhere you can take. You can take here, okay? Anywhere you can take. If I want to calculate slope A, B, C. So slope is what? Slope is AB divided by BC. AB divided by BC. See here. AB is what? AB is from here to here, it is what? 40. from here to here, how much it is? It is 20. Okay. So what you can write AB as? AB is 40 minus 20 will give you what? AB. So 40 minus 20 divided by time. Time here is what? 8. Time here is what? 4. So 8 minus 4 will give you what? Will give you the time. So 8 minus 4. So 40 minus 20. 40 minus 20 is what? 20. 8 minus 4 is what? 4. So this is what? 5. So 4 5s are 20. So what is this? This is the what? Shortest distance between A and B. Instead of going here, this is what? Shortest distance between A and B. Shortest distance is what? That is nothing but displacement. So displacement, this is what? Change in time interval. So displacement divided by time interval, it will give you the velocity. So what you can write is meter per second. So from the slope, what you have calculated? You have calculated the velocity. So what you can write? Slope of position time graph gives you what? Gives you velocity. Position time graph will give you what? Velocity, or you can say distance time graph or displacement time graph. Okay. So this is what, or you can also write as displacement or distance time graph. Position time graph or distance time graph will give you what? Will give you the velocity. So since it is a positive velocity, so displacement is what? In the positive x direction. No need to worry about that one. This is how we can represent your motion on the graph. So from the graph, what you can understand here, anywhere you can take the slope. You can take slope here also. So what you will get? 10 by 2. Again you will get 5 over. This is 20 minus 10 is 10. 10 by 4 minus 2, 2. Again what you will get? Slope 5 only. Suppose if you take a slope somewhere here, here also, 10 by 2. Again 5 only. If you take slope somewhere here, so this is what? 40 minus 30, 10 by 2. Again 5 only. Velocity is what? Velocity is same. If velocity is same everywhere, so that is what you can say uniform. Motion is what? Uniform. Okay. By looking at the graph, only you can tell whether it is uniform motion or non-uniform motion. So I will take another example of non-uniform motion. Suppose body started from here from 0, and in 2 seconds it comes to say 10. Again for 2 seconds it goes to say suddenly some 50. Again after 2 seconds, means it is 4 seconds. This is 6 seconds. It will directly go to say some 80. Or this only I will take it as 80. Here it will directly go to some 60. Here it directly go to some 100. Okay. So now if I plot this motion along the position time graph, so what will happen? So position I will take along the y and time along the x. Y, x. So now 2, 4, 6, 8. You have to write about the what value you are taking also. Suppose here one division or 1 centimeter equals to what? 2 seconds. So that you should be practice of writing what? Scale. So that will help you in the practical. So here how much you want? You want 100. 100 means so what I will do is I will take the small values over here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. So distances from the origin. Now for 2 seconds, where is the position? 10. So for 2 second position is what? 10. This is what position. For 4th second position is 30. For 4th second position is what? 30. For 6th second position is suddenly 60 here. So what you will get? You will get it as here. This is what going to be. Okay. Now you can understand it is not going to be a straight line. Okay. So this is what. Now for 8th it is going to be 100 all of a sudden. For 8th one it is going to be 100. Okay. So this is it. Now if you join them, so from here to here it is like this. Again from here to here. Again from here to here. Here to here. Okay. So it is not a straight line. Now if graph is not straight line means velocity is not same. Means it is not a uniform motion. Okay. So now if you want to plot the graph, if you want to calculate this, by looking at graph what you can understand, it is of variable velocity. Velocity is what? Velocity is increasing. Velocity is constantly increasing. Okay. So now here also you can calculate the what? You can calculate the slope. So suppose if you want to calculate the slope. So what is this one? This is going to be what? Your displacement. So this is what? Slope is 100 minus 30 divided by 8 minus 4. 8 minus 4. So that is what? 100 minus 30. So this is going to be 70. 70 by 4. Okay. So for what you can write? 4 ones are 4. So this is going to be what? 30. So 30 means 17.5. So some value will get it as meter per second. But this will give you what? This will give you what? Average velocity. Total displacement by total time. We are taking a wide range. But this is not going to be same everywhere. It is not going to be same because that was a uniform motion. Velocity is same. But here it is not a uniform motion. So it is not going to be same. Suppose if you want velocity at this point, instantaneous velocity. Suppose if you want velocity at this point. Okay. If you want to know velocity at this point, means say time is say some I will take at this point. So and at 6th second you want to know what is the velocity. That means that is the instantaneous velocity. For that what you have to do? You have to draw the tangent. So what I will do? I will draw a tangent over here. So I will draw a tangent over here. For this tangent I am going to what? I am going to plot. I am going to get the slope. Slope I will take from here. So 80 and here I am going to get some 30. Okay. So time is what? So this is what? 80 minus 30 is there. Divided by time is here it is 4 but here it is not 8. It is going to be some 7.5. So 7.5 minus 4. So this is going to be what? Some 50 divided by 7.5 minus 4. So what you will get? You will get some 3.5. So this will give you what? That will give you what? Instantaneous velocity. So what it is? This is going to be 10 divided by. So some 47 you can write. Getting? So if you make it some 100 divided by 7, so what you make 2, so it means it is some 2, okay, 14.2 meter per second. Okay, so this is what how you can calculate the instantaneous velocity. This is what going to be instantaneous velocity. Okay, so this is how we can calculate the instantaneous velocity and average velocity from the given graphs. Okay, so still so many things are there with relate to graph. We will discuss in the next class.